Have you ever looked up at the night sky and felt a profound sense of wonder? Not just at the stars, but at the very fabric of existence itself. We live in a universe governed by laws, by constants, by a delicate balance of forces that make everything, from the smallest atom to the largest galaxy, possible. But what if I told you there are whispers, echoes from the edge of scientific understanding, of a universe that shouldn't exist, a place that defies everything we know about reality? Today, we're embarking on a journey not to a distant star, but to the very limits of human imagination. Let's start with what we know, or at least what we think we know. Our universe is fine-tuned for life. The strength of gravity, the charge of an electron, the speed of light. If any of these fundamental constants were even slightly different, the cosmos, as we see it, would be impossible. Stars wouldn't form, planets would be sterile, and we certainly wouldn't be here to ponder it all. Scientists call this the fine-tuning problem. It's as if the universe won the cosmic lottery against unimaginable odds. Some see this as evidence of a grand designer, while others point to the anthropic principle. Of course, the universe is perfect for us, because if it weren't, we wouldn't be here to observe it. But this explanation, while logical, feels a bit unsatisfying, doesn't it? It's like saying you won the lottery because you're holding a winning ticket. It doesn't explain how the winning numbers were chosen in the first place. This is where the story takes a turn into the truly bizarre. To solve this puzzle, some of the brightest minds in physics have proposed a radical idea: the multiverse. The concept is simple, yet mind-bending. Our universe isn't the only one. Instead, it's just one bubble in an infinite cosmic ocean, a vast foam of countless other universes, each with its own unique set of physical laws. In this cosmic landscape, anything that can happen will happen. There are universes where gravity is so strong that everything collapses into black holes. Universes where atoms can't hold together. And, by sheer chance, universes like ours, where the conditions are just right for stars, galaxies, and life to emerge. The multiverse elegantly explains our fine-tuned existence without resorting to miracles. We simply live in one of the universes where life is possible. Now, hold on to that thought, because we're about to go deeper. What if we could find evidence of these other universes? It sounds like pure science fiction, but some cosmologists believe it might be possible. When our universe was born in the Big Bang, it was a hot, dense, chaotic place. If other bubble universes existed nearby, they might have literally bumped into ours in those first few moments. Such a cosmic collision, a bruise on our universe, could have left a faint imprint on the cosmic microwave background, the leftover radiation. From the Big Bang, scientists at organizations like the Planck Satellite Collaboration have been meticulously scanning this ancient light, searching for telltale cold spots or strange patterns that could signal an encounter with another reality. So far, the evidence is tantalizing but inconclusive. There are anomalies, strange features in the data that don't quite fit our standard model of the cosmos. Could these be the first hints of a reality beyond our own? The first breadcrumbs leading us to a universe next door. It's a long shot, but the mere possibility is staggering. But the multiverse isn't the only strange idea born from the frontiers of physics. Let's talk about something even more fundamental: the nature of reality itself. We perceive the world in 3 spatial dimensions and 1 of time. But string theory, a leading candidate for a theory of everything, suggests that reality is far richer. It postulates the existence of up to 10 or 11 dimensions, most of them curled up so tightly that they're completely invisible to us. Imagine a tightrope walker. From a distance, the rope looks like a one-dimensional line, but for an ant on the rope, there's another dimension: the ability to walk around its circumference. Our universe might be the same. We're the tightrope walkers, oblivious to the tiny, curled-up dimensions all around us. These extra dimensions aren't just a mathematical curiosity. They could be the key to understanding why gravity is so much weaker than the other fundamental forces. The idea is that gravity might be leaking into these other dimensions, which would explain its apparent feebleness in our 3-dimensional world. Experiments at the Large Hadron Collider at CERN are, in a way, looking for these hidden dimensions. By smashing particles together at incredible energies, Physicists hope to create new particles that might pop into existence for a fraction of a second before disappearing potentially into another dimension. Finding such a particle would be a revolution, proof that the world we see is just a slice of a much larger, higher dimensional reality. So we have the multiverse, a sea of infinite worlds. We have hidden dimensions curled up beyond our perception. Now, let's combine these ideas and push our imagination to its absolute limit. What kind of universe shouldn't exist? A universe that actively breaks the known laws of physics. Consider a universe with 2 dimensions of time. In such a place, the concept of cause and effect would break down completely. An event could have multiple, contradictory outcomes happening simultaneously. You could be both alive and not alive, here and not here. The past, present, and future would be a jumbled, incoherent mess. It would be a universe of pure paradox, a place where logic itself ceases to function. Such a universe likely couldn't support any form of complexity, let alone life. It's a universe that, by its very nature, seems impossible. Or what about a universe without the arrow of time? Our universe is governed by the second law of thermodynamics, which states that entropy, or disorder, always increases. An egg can break, but a broken egg can spontaneously reassemble itself. This forward march of entropy is what gives time its direction. But what if there was a universe where this law didn't apply? A universe where entropy could decrease, where broken eggs could put themselves back together, and where time could flow backwards as easily as it flows forwards. It's a concept that challenges our deepest intuitions about reality. In such a place, would memory precede experience? Would you remember the future? The very idea is a philosophical and physical labyrinth. This is the kind of universe that shouldn't exist, because it would violate one of the most fundamental principles we know. And here's where our journey reaches its most profound and unsettling destination: the simulation hypothesis. What if this entire search, this questioning of reality, is all part of the program? The idea, popularized by philosopher Nick Bostrom, argues that if any civilization ever reaches a point of technological maturity where they can create conscious simulations of reality, they would likely run countless such simulations. If that's the case, then statistically, it is overwhelmingly more probable that we are living in one of those simulations than in the one single base reality. Think about it. The fine-tuning of the universe is just the parameters set by the simulators. The pixelated nature of reality at the quantum level? Maybe that's just the resolution of the simulation, the constant speed of light. Perhaps it's the processing speed of the cosmic computer we're living in. This is the ultimate universe that shouldn't exist, because in a sense, it doesn't. It's an illusion, a sophisticated, perfectly rendered program running on some unimaginable hardware in a higher level of reality. We, our thoughts, our loves, our discoveries, all just lines of code. This idea is impossible to prove or disprove, which makes it both fascinating and terrifying. Are the anomalies in the cosmic microwave background glitches in the code? Are the extra dimensions of string theory just hidden subroutines? This thought experiment forces us to confront the most fundamental question of all. What is real? If our reality is a simulation, does that make our experiences any less meaningful? If you feel joy, or sadness, or love, does it matter if the source of that feeling is real or simulated? The feeling itself is undeniably real to you. From the grand tapestry of the multiverse to the hidden dimensions of string theory and the dizzying possibility that we relive in a simulation, we've journeyed to the absolute edge of what we can conceive. These ideas aren't just wild speculation. They are the serious, if mind-bending, consequences of our quest to understand the cosmos. They are born from the gaps in our knowledge, the places where our current theories break down. They represent the frontier of human curiosity. The search for a universe that shouldn't exist is, in the end, a search for ourselves. It's a reflection of our own innate drive to question, to explore, and to push beyond the boundaries of the known world. Whether our universe is one of many, a slice of a higher dimensional reality, or a fantastically complex simulation, the wonder of it all remains. The fact that we can even ask these questions is, perhaps, the most incredible thing of all. What do you think? Are we alone in the cosmos, or just one reality among countless others? Let me know your thoughts in the comments below. Thanks so much for joining me on this journey to the edge of reality. If you enjoyed this exploration, make sure to hit that like button and subscribe for more deep dives into the mysteries of the universe. Until next time, keep looking up and keep questioning.